welcome to Vector Proof. Before we start, just a reminder that there is a notes jotter available for this video. Check the description below for a download link and you can work along with me as we go through the video. So just to begin with, we're going to look at a couple of diagrams. What we've got here is a vector A and a vector B. And all we're going to do is we're going to look to see what the other vectors are in terms of A or B. And so the first one here, A goes a right 4 and up 4. Now if you have a look at this one goes right 8 and up 8. And so that is twice the magnitude. And so we would call that one 2A. If we look at the one next to it, it goes left 2 and down 2. So that is actually a negative version because it's going in the opposite direction, but it's only half of the size as well. And so that is negative a half A. What can we say about those three lines though? Well, the key here is that all three of these vectors are parallel to each other. They are all on the same gradient. And the reason is they are all multiples of A. So we've got 1A, 2A, negative a half A, all just multiples of A. They have a common factor. In terms of these three vectors, they are all related to B. So B goes right 4 places and down 2. Well, in terms of this first one, this one actually goes left 8 and up 4. And so that is actually a negative 2B. The next one is actually just the same vector but as the original but in the opposite direction, so just negative B. And in the last one, it's following in the same direction but half the length, and so it's half B. Now again, if we compare the original vector with the ones we have here, we can see they are parallel, and the reason for that again is that common factor. They all have a common factor of B. Now if we start thinking about resultant vectors, if I add A and B together, I actually end up with this diagram here. Now, if I have a look at the three that I've created here, they're all built using versions of A and B. And so this first vector here, well, that is twice the length of A, so that is 2A. And then this B, well, that is twice the length of B, and so that is 2B. And so in total, that is 2A plus 2B. Now, if we look at the resultant vector there, well, that would look like this. Do we have a parallel line? Well, let's compare it. Yes, we do. It is parallel to A plus B. And the reason for that, we have a common factor, because I could actually rewrite this vector as 2 brackets A plus B. I've got a common factor of A plus B in both cases. In my next one, I have the negative version of A, and I also have the negative version of B. And so what I've actually got as a resultant vector is negative A take away B. Now, if we join that up to form the vector, is it parallel? Well, let's have a look. Yes, it is. It is parallel to A plus B. And again, the reason, we have a common factor. I could write that as negative A plus B. And there we go. Yet again, we have A plus B as a common factor. The final one is also made up of A's and B's. So I have negative A and I have positive B. Now if I put those together to make a vector, I have negative A plus B, or B take away A. Now if I draw the resultant vector, it looks like this. Now this one is quite clearly not parallel to A plus B. And the reason is that negative A plus B, I can't write that with a common factor of A plus B. There is no way to rewrite that with a common factor. So we've just seen that vectors are parallel if they can be written with a common factor, and therefore that's the first thing I'm going to do here in order to try to see which of these each of these vectors actually are pairs. And so 6a plus 3b, can I rewrite that? Well, I can take out a factor of 3 and then I would have 2a plus b. So now any other vector on the screen here which can be written as something with 2a plus b as a common factor will be a parallel vector. In 9a take away 6b, well again 3 is a common factor there of 3a take away 2b. And 3a plus 2b, that's as simple as that one can actually be. I've got 8a plus 4b. Well, that one I can take a factor of 4, gives me 2a plus b. And actually, straight away there, I now have a pair of matching parallel vectors. If I go to 6a plus 4b, well, that can take a factor of 2 brackets 3a plus 2b. And just careful here, we've got 3a plus 2b and 3a take away 2b. They will not be parallel. So carrying on, negative 3a plus 2b, I can't simplify that one. 3a take away 2b, I can't simplify that one. 6a take away 4b, well, that one I can put a factor of 2, so 3a take away 2b. And so now all I need to do is see if I can find matching factors in the vectors. Well, here we go. 3a take away 2b. I can see that here as well. And therefore, those two are a matching pair. 3a plus 2b. Well, we can see that. 3a plus 2b in both of those. And so they match. And finally, we have 3 brackets 3a take away 2b, and we have negative 3a plus 2b. Now this one is a little bit of a trick here, because I can actually match those together if I think about taking a negative outside of the bracket. So if I take the negative out, that becomes 3a take away 2b, and so now that does actually match with 9a take away 6b. So next we're going to look at the situation where we have ratios involved in the distance between 2 points. And so in this diagram we've been given that AB is the vector 2a and that AC is the vector 4b. And x is the point on BC such that BX to XC equals 1 to 3. Now what that means is, it means that the line BC has been split into 4 equal pieces. Like this. So in the ratio 1 to 3 would mean 4 equal pieces. And it then says that X is the point on BC such that BX to XC is 1 to 3. And therefore, the first piece would take me from B to X. The next 3 pieces would take me from X to C. And therefore X must be this point here. Now, the reason that that is important is that I'm looking for the vector AX. So I need to know how to get from A to X. And to do that, I need to think about the journey that would need to be taken. I would need to go from A to B and then from B to X. Now the problem is I don't know a vector to get from B to C, and so I need to find that vector using the diagram that I already have. Therefore, to get from B to C, I need to just have a look at how I would get there. Well, I would start at B and I would have to go to A first, and that would be in the opposite direction of travel than the vector is showing, so it would be negative 2a. I would then need to go down the vector from A to C, which is plus 4b. So that is the vector from B to C. But in our journey, we actually only want to go from B to X. And so, to get from B to X, well, I need to think about what proportion of BC I'm actually dealing with. Now, because this is a ratio of 1 to 3, it's got 4 equal pieces. And so this piece is 1/4, and this is 3/4. And therefore, BX is 1/4 of BC. And so it's 1/4 of negative 2a plus 4b. And if we want to write that out, we could just say, well, that is negative 1/2 a plus plus b. But the question was, how do I get from a to x? Well, ax requires me to travel from a to b and then to x. And so first of all, if I want to go from a to b, well, that is 2a. From b to x, well, that is negative 1/2 a plus b. And if we simplify all of that, what we actually get is that ax is 3/2a, that is 1.5a plus b. So next we have a similar situation. We've been told that a to b is 2a and that b to c is b. X is the point on AC such that ax to xc equals 3 to 2. So straight away, the first thing I'm actually going to look at here is actually placing that point x on my line. And so in the case of this one, it's 3 to 2, which means it's actually 5 equal pieces this time that we've split it into. And the ratio from a to x is 3 and x to c is 2. Therefore, 1, 2, 3, that must be x, so it's 3 to 2. And in terms of a fraction, let's just have a look there. This fraction means that this piece is 3/5 of AC and this piece is 2/5 of AC. Now, we are looking for the vector bx. So eventually what I want to do is be able to get from b to x. And so in order to do that, I'm going to have to take 2/5 of CA. And so the first thing I want to know now is, how do I get from C to A? Well, CA, that would be following the vector b in the negative direction, so negative b, and then also the negative version of 2a. So negative b take away 2a. That is C to A. But in the question, I need to get from C to X. And so from getting from C to X, well, that is going to be 2/5 of this journey. So 2/5 of negative b take away 2a. And in order eventually, like it actually asked for b to x, well, that means I need to start at b. I'm going to follow the first vector, which is actually just positive b, but then I'm going to have to add 2/5 of negative b take away 2a. And we do want to give this as simply as possible, and therefore 2/5 b plus 2/5 of negative b, well, that gives me 3/5 of b, and then take away add 2/5 of negative 2a, well, that is negative 4/5 a. And so that is the vector from b to x. We've had to use vectors that we already knew, but we've also had to take into account that there are a fraction of a certain vector being used. So now we have the situation where we have a diagram. AOB is a triangle, and x is a point on AO. So we'll notice it's been marked here that x is on the line AO, and it tells us that AB equals 6a. So the first thing we need to just be careful of there, AB means that it is travelling from A to B, and that is 6a. And AO equals 10b, therefore AO means it travels in that direction, 10b. And AX to XO is 3 to 2. So again, what we've got here is that ratio situation. And so because it's telling us it's 3 to 2, that tells me that this is 3/5 and this is 2/5. We've broken it into 3/5 and 2/5 of the line. So what it wants is to start with is to find the vector OB in terms of A and B. So what I need to do is travel from O to B following vectors which I already know. So I'm going to go down from O to A. So that is in the opposite direction. That is negative 10b. And then it is following the direction of AB, and therefore plus 6a. And if we just want to make that look a little bit neater, we'll just write it as 6a take away 10b. And so that is the vector OB. It tells us that y is the midpoint of OB. AB equals AB to BC is 1 to 2. So show that XYC is a straight line. Now there is quite a lot in this question that we need to do before we get to the actual straight line part of it. The first thing is that we need to recognise that y is the midpoint, meaning it is halfway. OY and YB are the same length. Now we've already worked out what OB is. We know that OB is 6a take away 10b. So what we can actually say is that the first part here is 3a take away 5b. It is half of it. But we also know that this is 3a take away 5b because they are the same length. Along the bottom of the diagram, we were told here that AB to BC is 1 to 2, meaning that this length here is twice of AB. Now AB we have called 6a, so BC must be twice that. It must be 12a. And then if we have a look at x, y and x as well, we had our 3/5. So what we can actually say here is that a to x, well that is 3/5 of 10b, so that is 6b. And OX, well that is, XO is 2/5, so that would be 4b. All of this is going to come in handy for the very last part, showing that x, y and c is a straight line. And the reason for that is what we need to show is the vector xy. How do I get from x to y? Well, x to y would be 4b, and then following this this vector here, it will be plus 3a, it will be take away 5b. So xy is actually 3a take away b if we simplify. If I then look for how to get from x to c, the other point that was listed in XYC, to get from x to c, well I would need to follow from x to O, so that is 4b. I would need to go from O to y, or straight to b. I could go straight to b at this point, so 6a take away 10b, and then follow from b to c, which is add 12a. If I simplify all of that, I get 18a take away 6b. Now, the question was to show that XYC is a straight line. Well, how do we actually show that something is a straight line? Well, it comes back to what we were doing right at the very start, trying to prove that vectors were parallel. And to show that things are parallel, we looked for a common factor in the vectors. And this one, if I divide everything by 6, I could write xc as 6, 3a, take away b. Now, what that is showing is that xy is parallel to xc. So that is the first point in telling us that it is a straight line. We've proven that they are parallel. But also, because they both begin at x, they must actually be on a straight line. That is the proof of a straight line. If the lines are parallel and they share a starting point, then they are the same straight line. Okay, so we finish with the exam question. It came from the Edexcel mock papers and it was on higher paper 3. We've got a diagram given, some information about it, and we're told that D is the point on BC such that BD to DC is 3 to 1, and we need to prove that ADE is a straight line. So what we need to do here is just have a look down the information to see what is already on the diagram and what we can add. So AB is 3A, that's already there. AC is 2B, that's already there. BE is 3 lots of AC. That is not on the diagram just yet, but what that's telling me is that if this is AC, then BE follows the same direction and it is 3 times the length. So 3 lots of 2B, well, that would be 6B. So we are trying to prove that ADE is a straight line. So what we are going to need in our answer, we're going to need the vector AD and we're going to need the vector AE. Because if we're going to prove that they are the straight line, we need to prove that they are parallel and they have the same starting point. And so AE is actually quite a straightforward one to find. If I want to get from A to E, I will travel from A to B, which is 3A, and then travel from B to E, which is 6B. So let's just call that 3A plus 6B. If I want to get from A to D, well, I need to first think about the fact that that includes a journey along CB. And in this case, we were told that BD to DC is 3 to 1. And so this is 3/4 of the line. This is 1/4 of the line. Now, I need to find out what CB is. So how do I get from C to B? So to get from C to B, well, I will need to follow the vectors I already have. So that is negative 2B and plus 3A. But CD is only a quarter of that. And so a quarter of CB is going to be negative a half B and plus 3/4A. Now, if I need to get from A to D, well, I'm going to have to move along 2B and then subtract a half B and add 3/4A in order to travel along AC and then CD. I need to simplify that. So when I simplify, 2B take away a half B, well, that's 3/2B, and that's plus 3/4A. So we could write this in decimals. This would be 1.5B plus 0.75A. So if I wanted to actually get a common factor here, the common factor will be 0.75. It will be the 3/4. And that gives me 0.75 brackets 2B plus A. And if I look at AE, well, the common factor here will be 3A plus 2B. Do we have a common factor? Well, all we need to do, just to make it very clear that we have a common factor, is just to write this the other way around. It will be A plus 2B. There is our common factor. Therefore, we have 2 parallel lines and they both start at the same point. So they are parallel and share a starting point. That is our proof.